In this problem, we're given quite a lot of information, so let's read carefully what we have. The timber wolf population in Wisconsin is shown below for various years. So here in this table we have some different years from 1989 to 1993. We have the population, and remember population, they told us up here this is the population of timber wolves in Wisconsin. And then over here we have a blank column that's asking us to fill in some information about the change in population. So it's always a good idea to know all the pieces of a problem before we begin. So in part A, we're going to be asked for the years listed, find the change in population from one year to the next. In part B, we're being asked to find from which years to the next is the change in population the greatest, what is the change? And then in part C, from what years to the next is the change in population the least, what is the change? So let's start off with part A, where they're asking us to find the changes in population from one year to the next. So if we think about the change in population, notice that up here I've just made a little note about what change means. So change is the ending amount minus the beginning amount. So let's see what we've got here. Well, in 1989, because we don't know the previous year's population, we're not really able to talk about a change that year because this is the first year that we have, so we won't have any answer for that one. In 1990, well, the population was up at 40, so we can say that the change in the population, the ending population in 1990 was 40, and if we subtract the beginning population, which would have been the population in 1989, that would give us a change of 6. And then we're going to continue doing that same thing. And remember, it asked us to find the change from one year to the next, not from overall always starting back at 1989. So it's just from one year to the next. So this next one, in 1991, the population was 45. If we subtract the population from the previous year, we can see that there was a change of 5. Now this next one we have to be a little bit careful of. In 1992, notice here that the population dropped. So when we do our subtraction, 40 minus 45, because we want to be sure that we take the ending amount minus the beginning amount. So 40 is the ending amount, 45 was the beginning amount. When we do that subtraction, notice that that gives us a negative change. We have to be sure that we include that negative sign because that's what makes sense, because we see that the population here is dropping. Now from 1992 to 1993, we can see that there was a big jump, so we would expect that our population is going to be back positive again. So 57 was the ending amount minus 40 to give us a change of 17. Okay, so there we found the changes in population from one year to the next all the way along. So here now the next thing they're asking is from which years to the next is the change in population the greatest? Well, if we go back and we take a look at these, we can see that here from 1992 to 1993 there was a change of 17, so that's certainly the greatest. So we would say from 92 to 93, the change was 17. And then for the next from what years to the next was the change in population the least, well, notice that there were two where the change, both of them had an absolute value of 5. There was one year there was a change of 5 and another year where the change was negative 5. And so that the change amount, when we talk about the change, because that these pieces are going to be the same, then we could say that the change was the least from 90 to 91, or 91 to 92. And those changes were 5 or negative 5. So when we're talking about the kind of the amplitude, the amount of the change, we're going to be thinking about the absolute value of those numbers. So the fact that one is positive and one is negative doesn't really matter in this case. So we've answered all the parts to that problem.